We're back. Hello, everyone. Um, my name is Verdi Arbusto. This is the Schumann Resonance Harmonics channel on YouTube and Facebook. This is kind of a marathon session for me because I've done, this is the fifth in the series. Still wearing the same RISD shirt. I want to get this out. This is kind of important stuff. This is one of those long-standing issues that people have had and have continuously commented on. It's on the back burner, and I wanted to kind of bring it out in the foreground. And that is the magnetic pole shift. Where we're at in the narrative here is that we're looking at the magnetic pole excursion before the pole shift. Okay, so I've made a number of videos on this particular topic. It is that important. And before we can answer the question of how is this pole shift going to affect the Schumann resonances, as I refer to that as the extra credit question, I need to, stick to the meat and bones of what we're looking at, and that is the magnetic pole shift itself. And the topic question is, what is the magnetic pole shift, and what does it mean for everyone, for the Earth, for everyone? All right. So I'm bringing out into my channel, and hopefully the other people that look at, my channel will kind of also, look at the videos as well. So I want to also provide a resource. So you have, the information is in the description and all of that. All right. So, excuse me, the last video I posted, I played some of this, like half of it, and I was going to pick up where I left off, but I'm like, you know what? I'm just going to play the whole thing because I think it's worth, this is the topic, this is the discussion at hand. I think it's worth hearing this video all the way through. I think if you heard it once, fine, it's enough. You hear it all the way through. I've heard this a few times. It's on my playlist. So without any further introduction, I think, where am I at my timer? Oh, of course I don't have my timer on. All right, hold on a sec. Just checking the timer, 2:39 I'm at. These videos are 10 minutes. I love having 10-minute videos. That's all the length of a video that I should have. And some of them have gotten cut short, but I know approximately where we're at with it. So, excuse me, pardon me. All right, so without any further introduction, this is from Suspicious Observer's YouTube page, and I'm going to play this, and then we're going to have a discussion afterwards. All right, so from the top, and that's why I have the headphones, so I can hear and it doesn't interfere with the...
It does not take much research to learn that magnetic reversals on Earth happen hundreds of thousands of years apart. So what is the excursion? How does it differ from a full magnetic reversal? We have been examining the effects of magnetic changes on Earth, potential cataclysms that may arise, but there are those studying another form of great change during these magnetic events, a slower version of extinction, an appearance of new species, and which doesn't require a single short-term catastrophic event. A recent paper in the world's #1 geophysics journal highlights this disaster that looms on the geological horizon, but it's not something that happens hundreds of thousands of years apart.
We call them excursions. Magnetic excursions, which is, a term that's well integrated in the literature now, and these are very short-lived reversals, but they're associated with minima in field intensity, and it's the minima in field intensity that are implicated because when you have low field strength, you enhance UVR.
So unlike the full Cron events, the full magnetic reversals, these excursions are very short. They happen relatively quickly and return, but they include the dreaded minima of magnetosphere strength. So this begs the question, how often do they occur, and when, oh when, was the last one?
Well, as we head back in time from today, there are a number of very well documented excursions, magnetic excursions. One is at 40,000 years, which is called the La Champ excursion. And then as we head further back in time, we have another very well documented one, which is called the Blake excursion at about 115,000 years ago. And then we have one that's at 190,000 years ago. And then there are a number of other excursions that are not so well documented. And there's one at about 13,000, another one at about 32,000. So there are a bunch of them. The reason why they're difficult to document is that, as I said at the beginning, they have short durations. So it's difficult to record them in geologic archives.
Would it be possible that the Mono Lake or Lake Mungo excursions have evidence that is there, and it, because, you know, for the reasons you've described, it's just too hard to find, or we haven't found it yet, to call it a more recognizable event? Yeah,
I'm sure that's the case. I mean, although the first magnetic excursion was identified 1967, I think. So it's been a long time since the first excursion was actually discovered in the geologic archive. But their discovery is fairly fortuitous because they're so brief. Sediments. They're recorded in some sediments, and they're recorded also by volcanic rocks. But you have to be very lucky to catch, that there's an eruption of a volcano at the right time, or that the sediments are deposited just at the right time to record the excursion. So that's why the recordings are not very common. We don't visualize a blitzkrieg process of extinction associated with UVR. And we state this in the paper, that we're looking at a process that affects a population over multiple generations. And it's related to the way in which UVR stimulates mutations that eventually affect the genome. So it's not a blitzkrieg process related to UVR that causes these extinctions. It's a progressive process that becomes important over multiple generations, perhaps over 1,000 years, when the field strength was low. And, I think one of the key points, too, is the issue about the aryl hydrocarbon receptor that differs in Neanderthal and in modern humans, and what role that plays in the susceptibility of UVR for Neanderthal.
Would it be completely out of range to suggest that whenever it is this happens again on Earth, because it would be kind of nuts to think this is never going to happen again, when this happens again on Earth, is there reason to suspect that perhaps modern humans are in a better position to handle the ultraviolet changes?
Well, certainly modern humans managed to survive 40,000 years ago when the Neanderthals died out. So they were better equipped than Neanderthals to survive the high UV environment. So that's true.
Mm-hmm.